Hello and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL gruntwork out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/RudderStack. Modern data teams are using Hex to 10x their data impact. Hex combines a notebook-style UI with an interactive report builder. This allows data teams to both dive deep to find insights and then share their work in an easy-to-read format to the whole org. In Hex, you can use SQL, Python, R, and no-code visualization together to explore, transform, and model data. Hex also has AI built directly into the workflow to help you generate, edit, explain, and document your code. The best data teams in the world, such as the ones at Notion, AngelList, and Anthropic, use Hex for ad hoc investigations, creating machine learning models, and building operational dashboards for the rest of their company. Hex makes it easy for data analysts and data scientists to collaborate together and produce work that has an impact. Make your data team unstoppable with Hex. Sign up today at dataengineeringpodcast.com/hex to get a 30-day free trial for your team. Your host is Tobias Macey, and today I'm interviewing Matteo Pelati about Dozer, an open-source engine that includes data ingestion, transformation, and API generation for real-time sources. So, Matteo, can you start by introducing yourself?
Hello, I'm Matteo. I'm originally from Italy, based in Singapore. I'm been in engineering for the last 20 years and about 12, 13 years working on data. I've worked for a startup and mostly financial institution, been part of Data Robot quite early. I've set up the data team at DBS in Singapore, and right before starting Dozer, I was leading data engineering for Goldman Sachs in Singapore, in Asia Pacific.
And do you remember how you first got started working in data?
Well, I first started working in data when I was at Nokia. Actually, that was I think it was around 2008 actually, and there was no big data at that time, but we were processing log data from the telco equipment. So in reality, it was big data, even if the term was big data was not invented yet.
And now, bringing us up to what you're building at Dozer, can you give a bit of an overview about what it is and some of the story behind how it came to be and why you decided that you wanted to invest your time and energy on it?
Yeah, sure. So the problem that we're solving at Dozer is fundamentally exposing data to be for the integration to customer-facing application. And how I encountered the problem was when I was at DBS that we had to build an entire data infrastructure layer for serving APIs to mobile application. And it was across multiple countries, across multiple products, and it was a massive project with a lot of moving parts, a lot of custom code to be built, a big team, and took quite a bit of time. And that's where I solved this problem in DBS. I saw a similar problem when I was at Goldman Sachs. Then, talking with friends in the data space, I noticed that this is actually it's apparently a simple problem, but in reality there is a lot of complexity behind. And that's how we started. Me and Vivek, my co-founder, started thinking about Dozer, and then we started doing some research, and we found other projects that tried to address similar problems. One of the projects that is pretty well known is the project called Dozer. Actually, that's where we got the inspiration from. That is a project from Netflix that solves a similar problem. And then we started thinking, okay, this problem has this problem has legs, and that's how we started. So basically, we started fundraising, we started the company, we started the open source project, and here we are.
And in terms of making it open source, what was your decision process that led you to that conclusion?
Well, the data. I mean, now open source is getting more and more popular. But if you look at the data space, pretty much every project is open source, and I don't believe there is any. I mean, I don't believe today is possible to make a project successful in the data space without being open source. So for us, it was kind of a given that this had to be open source.
In terms of the actual problem space that you're addressing, as you noted, there's overlap with a number of different technologies and use cases. And I'm wondering what it is about Dozer and the overlap of the Venn diagram across those different technologies that makes Dozer a better fit for the specific problems that you're focused on versus any of those other solutions. So, in particular, things like Flink for streaming, or Airbyte or Fivetran for data integration, or things like Cube.js for data APIs. I'm just wondering what it is about Dozer and that particular intersection of problem spaces that made it useful and necessary to build this product.
Yeah, that's right. That's a really good question. So the way we position the product is, as you mentioned, if you want to bring up an entire infrastructure for serving data, you have to put together multiple technologies. And then you have the problem of real-time data and the batch data. You have different type of caching, different type of lookup that you have to perform. So the technology is start becoming more and more, and the infrastructure, the architecture become more and more complex. Now imagine where you have a product engineering team that needs to integrate data with a customer-facing application. Now, they face a problem of talking with the data engineering team. They basically talk a different language, actually. So what we want to enable with Dozer is the ability for a product engineering team to be kind of independent and say, okay, I can source my data from my data lake, from my operational systems. I can source everything in real time. I can do some transformation because what is available there in the system is not exactly what I want, and I want to easily expose it as API and be able to integrate it with my customer-facing application. And I want to do it, and I want to do all this without bringing up an entire infrastructure, but I can have a simple tool to do that. Another consideration that we have done is the fact that we feel the world of data engineering is changing a lot. I mean, it has been primarily dominated by the JVM based tools, and most of them use a distributed architecture now. And in many situations, you don't really need that kind of complexity. So with new languages like Rust, new processor coming out, ARM-based processor with a large amount of cores, we feel today it's possible to achieve on a single machine what before needed a distributed architecture. So you put everything together and say, okay, Dozer is a tool that allows, our idea is Dozer is the tool that allows product engineers to build this entire end-to-end experiences.
And because of the fact that there are multiple steps in building that experience, and that has largely been addressed by a number of different technologies that have to get stitched together, what are the major points of friction that you have seen teams run into as far as building those solutions with those different technologies? And what are some of the elements of the user experience that you're designing into Dozer to reduce that overall friction?
Yeah. So the friction that I've seen is it's a typical friction that you have in an enterprise where you have your product team and your data engineering team. The data engineering team focuses more on the big picture, and they want a kind of like the perfect data platform to be implemented in the enterprise. While the product team, they want something that is readily available to be consumed by API. That's a friction that I've seen. And sometimes the pulling data from your data platform might not even be enough. For example, because if you need real-time data, if your data platform doesn't have a full real-time streaming infrastructure yet, so that's a challenging problem for the data engineering team. The other aspect that is very important here is that since we focus on serving data to customer-facing application. Obviously, you have a different set of problems from the data engineering team. Data engineering has primarily been used for internal consumption. So if a report is not ready, for example, one day, that's a problem, but it's not a critical issue. Now, when you start putting that data in front of the customer, obviously you need another level of reliability, because it's data that needs to be available 24/7 at a particular SLA. So, and that's what we address also in Dozer, is about the monitoring of the system, or the let's say, I would say, the data observability from this point of view, and the understanding when problems happen, being able to resolve that problem, because you're serving customers. So that's the philosophy behind it. Actually, obviously, we are very early right now, but that's our vision.
Another aspect of this cross section is that there are a number of different personas or roles that are typically involved in some of the different desired end goals, where for building a data API, it might be an application engineer who just needs to integrate data into their application. It might be a data engineer who's trying to provide output to a machine learning or an analytics use case. It might be a data scientist who's trying to build some experimental system to determine whether or not the direction they're going is the right path. And I'm wondering, because of the fact that you do have so many different target audiences, how that also factors into the way that you think about the design and usage of Dozer to be able to address the needs of each of those personas.
Yeah, I mean, fundamentally, the whole idea is that it goes back to the simplicity of usage. So you just connect your data sources, you express your transformation using SQL that is translated into a streaming pipeline, and data is cached in the API. So these are usually three distinct components. It's an ingestion component, a streaming ingestion component, it's a transformation engine, and it's a caching layer plus API. We say our philosophy is that because we want to give the possibility to a single developer or a small team to orchestrate all this. We say, okay, this is just a configuration file. We use YAML, and we're going to have our cloud base with a UI available really soon. But fundamentally, you can express ingestion, transformation, and caching all in a single configuration, so that you can bring up the entire infrastructure. Some people called it data as code, actually, as comparing it to infrastructure as code, which is a good analogy. But that's the philosophy we have behind.
And digging now into Dozer itself, can you talk through some of the ways that it's implemented and the architectural elements of it that make it a better fit for this end-to-end data integration and delivery use case?
Dozer is fundamentally a self-contained tool. We didn't want to have a dependency to external tools like Kafka or distributed key value store. So we wanted to keep it very simple. It's all implemented in Rust. That gives us the performance. And it's fundamentally three pieces. One piece is the ingestion part. So we always treat data coming in as streaming data, whether it's actual streaming or not. Like, I give you an example. Relational database, easy to think, we use CDC to capture all the changes. But even when you are dealing with a Snowflake or Delta Lake, which is not strictly something real time, we basically capture change streams to detect what has been changed, and we update the state. After the ingestion, we fundamentally have a streaming SQL engine that has been built from the ground up, and this is let's say quasi NC SQL. Actually, we support all the pretty much complex operation, aggregation, joins, etc. And this allows us to basically allows the user to create a model by joining sources, aggregating, that then will be stored in the caching layer. Once the data is transformed, everything is is stored in our caching layer, which is not which is an embed based on an embedded database. We leverage LMDB actually, which is a very fast memory mapped key value store. And on top of that, we have the API. Now this is the execution engine. Obviously, on top of it, there is a lot of stuff to handle API, like for example, automated API versioning. So what happens when something changes in the source? We automatically detect that change. We basically detect if it's backward compatible or not and create a new API. So all the typical problems that engineers have been dealing with API, we are bringing the solution to those problems to the data world. Now, all these can be run as a single binary or can be run with different binaries. But the fundamental idea is that you can just do a brew install and basically put down a YAML configuration file, and you have one process basically connecting to the database, doing the real-time processing, and exposing low latency API. That's how it works. Another thing to note that the philosophy, the approach that we have taken is that because everything is pre-aggregated, so the idea is that complex aggregations and joins, you do that in the SQL layer, and the simple operation, you do them directly on the cache. Like the cache allows you to do filtering, sorting, basic operations. If you have anything more complex than that, you do it upstream. That's fundamentally the idea. That allows us to guarantee the sub-millisecond latency on every request.
And building up a streaming engine and a SQL engine in the same unit is definitely a very complex set of engineering challenges. I'm curious, what are some of the sources of inspiration that you drew from to be able to understand how to address this problem, and some of the off-the-shelf components that you were able to use to build out this overall architecture?
Okay, yeah. So we didn't use many off-the-shelf. I would say off-the-shelf components. We use LMDB definitely. That's the caching layer that we're leveraging. For the caching layer on top of LMDB, obviously we've built some indexes, an additional layer, and there is a lot of literature about that and a lot of projects doing that as well. On the streaming SQL engine, obviously we got some inspiration from the tools that are out there. For the caching layer, we leveraged LMDB. It's a database we like a lot. Actually, we did a lot of testing comparing RocksDB versus LMDB. I previously in the past used a lot LMDB and I like it a lot. And RocksDB is very good for heavy writes, and while LMDB is very good for heavy reads. And that's why we decided to go that direction. Talking about the streaming SQL, obviously that's it's a complex piece of code, but it's other companies are embarking into this. So we got inspiration from the traditional real streaming SQL tools like Flink, for example. So that's and the value for us is being able to give the end-to-end integration of all this without letting the user handle all these moving parts.
As far as the evolution of the project, I'm wondering what are some of the design and goals of the project that have changed since you first started working on it, and some of the assumptions that you had going in that have been updated in the process?
Yeah, so I would say that when we started out, we had this idea of having a single binary deployment actually, and that was how the project started, and that's how was the first version. The first one was. Later on, now we are starting to work on our cloud version. And not everything is best suited to be a single binary deployment, actually. So our cloud deployment is entirely based on Kubernetes, so we realize the need of separating up some components, and that's what we are actually doing right now. So I would say that the we still want to be able to run it as a single binary, but sometimes for operationalization, that's probably not the best, and that's why we're kind of like starting to separate it in various components. That's probably the biggest change that architecturally we have done.
And so for people who are getting started with Dozer, they want to deploy it and integrate it into their existing infrastructure, or start pulling data from their various sources. I'm wondering if you can talk through the overall process of getting that set up and integrated and configured.
Yeah, so the process is very simple. I mean, we have a documentation on our website. So fundamentally, you can download it. So you can download it using Brew or use a Docker image. And we have a couple of samples as well that where we show how we connect to Postgres database. How we are constantly adding samples. We can pull data from S3, how we combine them together, etc., etc. And it's fundamentally writing a YAML file where you define the sources you want to connect, the SQL transformation that you want to run, and the endpoints that you want to expose. And that's pretty much about it, actually. So then you start Dozer, and automatically you have APIs. We are working on the more details on the deployments. As I mentioned, we are working also on our cloud version, which we plan to release about next month. And yes, and also more and more samples. I mean, we are working on more integration with more sources, and that will ease the onboarding of the user. But if you want to get started, that's straightforward. It's just 2 lines of code, and we also have a couple of videos showing tutorials showing how to do it.
And once it is deployed, you've got it connected up to some of your different sources. Can you talk through the developer workflow and the process involved for teams who are building out some of these different data applications, some of the elements of access control, multi-tenancy, things like that?
Yeah, talking about, yeah, I forgot to mention that we have client integrations as well. So we integrate. We have a JavaScript client. We have a Python client as well. So if you are consuming the data from your web applications or your data science application using Python, we provide a client that easily integrates with API and easily integrates with authentication. For authentication, we are currently our authentication is our authorization. We don't really handle authentication. We let you handle authentication yourself. It's all JWT based, and we handle authorization at the raw level. Field level authorization is coming soon, and that's how easy it is to integrate. As I mentioned before, we handle deployment of new API and versioning of API. So that means that whenever you, let's say, for example, you change your model, so you update your SQL because something changed or even the source changed, we basically detect that something is wrong. We notify you. We allow you to at that point you can update your SQL. You can deploy a new version of the API, and we let you basically switch the API when you've done integration. So fundamentally, it's kind of like a blue-green deployment for your data. That's how the workflow is from a product engineer point of view. That's how the flow works.
Other aspects that are interesting to talk through are some of the elements around testing, validation, working in pre-production environments, and promoting changes. I'm wondering if you can talk through some of those aspects of the development workflow and the maintenance and evolution of these applications that are built on Dozer.
Yeah, right. So this is something that is not much addressed in the open source version, and that's something we are implementing in our cloud version. So our cloud version will have the full life cycle of API management, allowing you to have to deploy in a let's say pre-production environment. And then testing the API there, and then promoting to a production environment. So that's this is something that is not going to come out next month. It will likely come out around September, but that's what we're working on.
Another aspect of any project that is open source but has a business behind it is the question of governance and being able to balance the needs of the open source project with the goals of the business and sustainability of both. I'm wondering if you can talk through some of the ways that you're thinking about those problems.
Yeah, right. Yeah. So the philosophy that we have is that open source will always be there, and we will always support it. Our idea is that the open source version will give all the features, but the scalability of API is up to the user deploying it, actually. So all the features will be available. There will be no features that are cut down in terms of for example, SQL connectors or API. What really will what is the added value of the cloud is the peace of mind. So API auto-scaling, global data distribution, etc., etc. So that's the way we're thinking about it.
And recognizing that it's still fairly early in the project, I'm wondering if you can talk to some of the most interesting or innovative or unexpected ways that you have seen Dozer used.
Yeah, sure. So as I mentioned, we are very early, but we started having different type of user leveraging Dozer for different applications. I would say that one application that came up in multiple situations is, for example, payments, where typically to run a payment system, you have to run multiple transactional systems. You have a CRM, you have the payment management. There are 3 or 4 different systems and databases that each one does a different role. And one of the requirements that you have in payment system is being able to aggregate all this data and give a unified view to your user. No. And that's where we have seen, for example, those are being used by multiple companies because payment is a scenario where you need real-time information. I mean, once the customer have done a payment, they immediately want to see what's going on. And querying all this transactional system in the backend is not really feasible. So there is the need of a unified view that is updated in real time. Actually, that's for example one of the interesting use case we have seen. There is another use case that came up that is more of a experimental. Is integration with LLM, for example. So now a lot of people are experimenting with vector databases and using LLMs to basically using vector databases as a knowledge base for an LLM. But if you imagine having building a chatbot answering question about the knowledge base, but if you think, let's take for example a bank, a knowledge base is not really necessary. You need to have a customer 360 in order to personalize the LLM responses for that user. Now, that customer 360 needs to be built and needs to be maintained in real time, needs to be up to date. And in order to build it, data comes from multiple sources. So you need to have a system that allows you to collect all this data, create a unified profile, and being able to serve that profile at low latency when the LLM to be provided as in the context of the LLM actually. So that's another interesting use case that came up. It's very experimental, but that's we thought it was quite unique and quite creative actually.
And in your experience of building Dozer and trying to grow the business around it, grow the community around it, what are the most interesting or unexpected or challenging lessons that you've learned in the process?
So from a technology point of view, I don't think there have been many surprises, I would say, because I've been in technology for more than 20 years, so that's easier. I think that most of the surprises came from the community aspect and community building, because I'm basically a newbie there, and I'm learning my way. And it's incredible how when you put out something, how people start, the curiosity of people, and the how much they are willing to help to contribute to the project actually, even if the project is very early. And as an engineer, you always want to wait to put out a project that is almost ready, not to burn yourself. But maybe that's many people say it's not right. I mean, it's debatable actually, but even putting the project relatively early, I believe you get a lot of support from the community. I mean, they want to be involved, they want to learn more about it, and it's incredible, how when you put out the project, it maybe is not fully ready yet. People still want to try and still want to solve the problem and contribute back, instead of like saying, okay, this doesn't work, and just drop it 5 minutes later. That is quite incredible.
And for people who are interested in building APIs on top of real-time data sources, what are the cases where Dozer is the wrong choice?
Dozer, it does integrate an engine that pre-aggregates data. So Dozer is a perfect choice when you know exactly what you want from the API, and you know the consumption pattern. Now, if you have a situation where you're doing more exploratory things, so you don't know exactly what you need, and you want to run different queries, and most of them are can be all up queries, Dozer is definitely not the choice here. There are other tools that allows you to ingest all the data and do all up queries on top of it. You can think about tools like Rockset, for example. You can think about Tinybird. Those are more, the philosophy of those tools is that you take all your data, you pump all the data in the system, and then you run queries in semi-real time there. Dozer, on the other side, is much more efficient when you say, I know exactly what I want. I know what kind of query I'm going to be doing, and I want the lowest possible latency. That's when Dozer fits very well.
And as you continue to build and iterate on Dozer, what are some of the things you have planned for the near to medium term?
So near term, near to medium is our. To be honest, now we are fully focused on cloud deployment actually, and at the same time enabling more scalability on our open source release as well. Other aspect is on the connectors side, so expanding the connectors. Now we have a limited set of connectors, and that's what we're working on, expanding them. And third is the UI. Right now, Dozer is fully based CLI and a configuration file. So we are working on a UI layer to be more easier usable for people who prefer that. Obviously, there are also longer term things, like there are longer term items that we're working on. What I mentioned before, the monitoring, observability, more work on the security aspect, as I said, field level authorization. So this is what is on our plate in the coming months.
And to the point of the source and destination integrations and also just the overall extensibility of Dozer, what are some of the interfaces or plugin options for people who are using Dozer to be able to extend it and innovate on it for themselves?
Yeah, so in terms of sources, currently we support Snowflake, Delta Lake, Postgres, S3 files. We have a connector for the Ethereum blockchain as well. So these are the connector we currently support. The connector, and we support also, I forgot to mention, is not strictly a connector, but it's basically a gRPC endpoint. So you can actually pump in data from your code as well. The connector model is very easily implementable. In fact, we have a couple of contributors that are working on a MySQL connector implementation, and another one who are working on a MongoDB connector implementation. So that's a pretty straightforward to implement. On the sync side, we don't really advocate for having multiple syncs. I mean, we are not strict. I mean, we have a streaming SQL engine behind, but we don't sell ourselves as a agnostic streaming SQL engine. Our sync is our caching layer, is tightly integrated with that, because that's our value proposition is be able to serve API. There's going to be one thing that we are exploring, actually, because it came up a couple of times, is the ability to plug in with an external key value store. That's something that we kind of started looking at it, but we are not sure about it yet. But that's the fundamental. I mean, most of our extensibility will be on the source side, actually.
Are there any other aspects of the Dozer project in this space of end-to-end data integration and delivery that we didn't discuss yet that you'd like to cover before we close out the show?
I think we discussed pretty much everything. I mean, I cannot think of other things that we didn't cover. Yeah, I think we discussed pretty much everything.
All right. Well, for anybody who wants to get in touch with you or follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Well, as I mentioned before, I think that there is a revolution in progress in the data management space that is driven by Rust. That's what I truly believe. I mean, we are actually going into a direction, a shift where we used to have fully distributed system. And now we started realizing that maybe that's not needed. Maybe let's go back to the roots. Let's go back to the single machine with multi-core, and that is and with much more efficient languages like Rust. And that is happening very much. Also, that is happening both in the streaming and in the batch space. I mean, streaming, there are multiple. There is Dozer. There are a lot of other projects like Materialize, Rising Wave, as you mentioned, Cube.js, all written in Rust. But if you look at the batch landscape as well, there is a lot of stuff happening there. I mean, a lot of people are excited about DuckDB, Data Fusion, Polars, and I believe that these tools will completely change the landscape of data engineering.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on Dozer. It's definitely a very interesting project, interesting platform. Definitely appreciate the time and energy that you and your team are putting into bringing that into the world. So thank you again for taking the time today, and I hope you enjoy the rest of your day.
Thank you very much.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.